Hi, Econ. Hope you guys are excited to tackle the last frontier as we learn about production possibilities frontier. So this is going to be a great application to opportunity costs and trade-offs and scarcity and all of the information we've discussed up till this point. So as you're learning, economics really builds on itself. So excited to dive into this with you today. It's going to be great. So let's take a look at our learning targets for the day. First, we'll be able to construct PPF or production possibilities frontiers to demonstrate opportunity costs of producing two different outputs. Then we will be able to interpret a PPF to make educated production decisions. And finally, we'll be able to describe the effect of external factors on a PPF graph. Okay. So as we've alluded to previously, and as you might have figured out, a PPF or a production possibilities frontier is a graph that we use when we have two different outputs. And this PPF then predicts the unique combination of outputs that can be produced when we allocate our resources. So we use PPF graphs for a variety of reasons, and economists say that they help us think on the margin, as we've talked about in the previous lectures. They help us calculate opportunity costs and trade-offs of producing different outputs given our resources and inputs that we do have. And finally, they help us establish goals for the future. So on this graph here, we see points A through F. For this first part of the lecture video, we're going to focus on points A through D and talk about what those mean. Later on, we'll talk about what E and F mean on a different graph, okay? So the key elements of a graph, before we get too far, just as a review, in case some of us need a little math refresher, a title tells us what is being shown on the graph, and every graph that you make for us needs to have a title. It needs to tell me clothes versus food production in the example of this graph over here, or brownies versus cookies in the example we'll see a little bit later. So the format is whatever is on one axis versus whatever is on the axis of the other in terms of the label. So it could be food versus clothes or clothes versus food. Really doesn't matter too much. The axes labels and units tell us what is being compared, what our two outputs are. Okay, so obviously in this economy or this business, they're comparing food versus clothes outputs. So it doesn't really matter if we would have put food on the x-axis or on the y-axis. That's just the way that we decided to do it for this graph. But at the end of the day, though, just be sure to include units or labels if they're not already given to you, because that's important so we can better calculate our opportunity costs to know exactly what we're looking at. So in the example on the right, we are going to create what is known as an allocation table showing the combination of quantities produced for food and clothes given our inputs. And finally, we're going to determine the opportunity cost to moving along from point C, which is right here, to point D, what we will be receiving and giving up in that transition period. So this is an allocation table, and basically it's a fancy schmancy way of saying what is being indicated on the graph here. So bear with me, this is kind of a weird graph because it doesn't really go in order of A, B, C, and D like the graph that we'll see later. It's A is down here, B is over here, and C and D are in the middle. So at point A, we see that there is no food being produced. We go over here, 0. But we're estimating about 175 units of clothes are being produced at this point. Okay, so on this allocation table, we can put 0 for food and 175 for clothes. Okay. At point B, we see there is 100 units of food and 0 units of clothes. Point C, 75 food, 100 clothes. Point D, 50 food, 150 clothes. Now in this example, we had the graph first and made an allocation table from that. In the examples we're going to be doing later, you are making the allocation table first and then creating a graph from there. Okay. So the big deal question here then for this part 2 is what is being given up or gained from C to D in order to calculate that opportunity cost. So think in your head, pause it if you have to. Hopefully you've reached the conclusion that we are going to be doing a little bit of math here to figure this out. The formula will be what we have at D in terms of food and clothes minus what we have at C, so D minus C. So for food, we would take 50 units minus 75 units, and for clothes, we would do 150 minus 100. And we know that we are going to be losing 25 units of food and gaining 50 units of clothes in making that transition from C to D. We can confirm this because we go down on our food and we go over or increase our clothes. Okay, so when in doubt, graph it out. Make sure it checks your math and also the graph visually. They're pretty easy, straightforward problems, but you just got to think with your head, be logical, and you'll get the right answer almost every time, guaranteed. Okay. So if you are confused on this or need a refresher, feel free to pause, rewind, whatever you got to do, as in all videos. But if you get it, just keep chugging along with me. Okay, so we're going to get into this fun little case study here that we're going to be building on throughout the rest of this presentation. So let's talk about Misty and her bakery. So she's got this bakery and she can make 6 pans of cookies or 8 pans of brownies every hour. And dang, that's pretty efficient. For me, it takes me like 2 hours to make 1 pan of brownies. So go Misty, but in this factory or this bakery, she works 5 hours a day. So per hour, she can make 6 pans of cookies or 8 pans of brownies each hour, okay? So we're gonna do 3 steps. Step 1 is going to be to create this allocation table. Step 2 is gonna be to draw a PPF graph, and step 3 is gonna be selecting 2 points and calculating opportunity cost. So if you understand how we're doing this, feel free to pause and then check your work at the end with me. Or buckle up, hang on, we can do this one together and we'll have some opportunity for individual practice here in a little bit. Okay, so the first step is to create an allocation table, and I have a nice little skeleton for you already. So in the problem, it notes that she works 5 hours. Now she could spend all 5 hours making cookies if she wants and spend 0 hours making brownies, or vice versa. She could make brownies all day and not make any cookies. Just her choice. Okay, so we need to include that when we are factoring in what we are going to be producing. So obviously she makes 6 pans of cookies per hour, and if she spends 5 hours making cookies, we would just do some simple multiplication. So 6 pans times 5 hours equals 30 pans of cookies. Likewise, she would spend 0 hours making brownies, and she can make 8 pans of brownies in an hour. So 0 times 8, 0 pans of brownies. And we're gonna go ahead and do that the entire way down, okay? So hopefully you kind of get some math similar to this. So 6 times 4, 6 times 3, 6 times 2, so on and so forth. And this shows us all of the possibilities, okay? Then we're going to make a PPF graph using this data, okay? So again, our PPF graph needs to have an x-axis and a y-axis. Doesn't matter which goes where, but for here we're going to put brownies on the x-axis and cookies on the y-axis. And we're going to have a title that says brownies versus cookies. Plain simple, tells me what I'm looking at, okay? So we're going to go ahead and go back to this data here and simply plot. So we know that for cookies, on the y-axis, one of our points is going to be 30, 0. So we go over here, we plot 30 cookies, 0 brownies. Go down to the next point, which is 24 cookies, 8 brownies. So 24 cookies would be somewhere in here, probably 8 brownies over here. And you're just going to go ahead and it will reveal a downward sloping trend like this. This is what your PPF graph should look like. Now, the reason I like calling it a PPF graph and not a production possibilities curve, and if I do refer to it as a curve, my apologies, but notice here this isn't really a curve shape, it's pretty linear. Sometimes though we can have PPFs that are curved out, which is why production possibilities frontier is the more correct way to say it, because it could be flat, it could be curved, whichever. It does not have to be a specific shape, it just depends on what is being graphed and the resources available. So the last step here is to select any 2 points and calculate the opportunity cost of moving from those 2 points. So for simplicity, just like we did last time, I'm going to select points D and C. So the opportunity cost of moving from C to point D. So imagine we are currently producing everything at C. We have to figure out what would happen if we move to D. What will we be gaining? What will we be giving up? So our formula then is D minus C. So we have to calculate that for cookies and brownies. So at point D, we're producing 12 cookies and 24 brownies, and at point C, we're producing 18 cookies and 16 brownies. So for cookies, we would just simply take 12 minus 18 to get negative 6 pans of cookies. So we will be losing 6 pans of cookies in the transition, and we'd be gaining 8 pans of brownies. So we are giving up 6 cookies in order to get 8 brownies. So depending on if she wants to produce more brownies or fewer brownies, this could be a good or bad transition. Or she could move along from C to B if she wanted to produce more cookies. Kind of see how that works? Okay. Now, this is where I would like you to pause after I give you some instructions. Okay. This is going to be an additional step, just like what we just did, but we're noticing that Missy got really busy. She was swamped. She needed to get some extra help because there was so much demand for her product. Okay, so she hired on Jenny after an extensive interview process, and Jenny can make 4 pans of cookies or 3 pans of brownies per hour, and she also works 5-hour shifts with Missy. Okay, so as you work through this problem, I want you to also make sure that you take into account how much Missy was able to produce, because again, Missy and Jenny are now a team. So Miss C was initially able to produce 6 pans of cookies or 8 pans of brownies per hour. Now we have to take into account what Jenny can produce too. So you're going to want to first create an allocation table like we did in the previous problems. Then you're going to create a PPF graph, and finally you're going to select 2 points and calculate the opportunity cost of moving along those points. So pause here. I'm going to fly through this, and then you can check your work with me and refresh yourselves if you need to. So the first thing is we're going to make our our allocation table. So we have our hours for cookies and brownies and possibilities plotted there. We know that if Misty is able to produce 6 pans of cookies in an hour and Jenny's able to do 4, as a team, they can produce up to 10 pans per hour. And with cookies, same thing. Misty can produce 8 pans, Jenny can produce 3 pans, so 8 plus 3 is 11. So we take 10 and 11 respectively, multiplied by the hours to make our possibilities. Then we plot this data on a graph, again, making sure that we have our x-axis and a y-axis labeled with a nice title. This is a beautiful outline of a graph. And we should see something like this, downward sloping, okay? And then we're gonna go ahead and label the points. So for my example, I'm going to select transitioning from point B to point D. I didn't mention this earlier, but you can make it from point A to point F or point E to point B. Like you can go any which way along the graph. But for this example, I'm doing B to D. So our formula then is going to be D minus B. So at point D, we produce 20 cookies and 33 brownies, and at point B, we do 40 and 11, and that can be confirmed in your table. And for cookies, we are going to be losing 20 pans of cookies in this transition. Okay, this can be confirmed because we are going down on the y-axis. And likewise, we will gain 22 pans of brownies because we are moving across. Does that make sense? Again, pause, rewind if you have to. Take your time on this. Okay, so if we plot both of these PPFs right next to each other, we notice that there's something different. So when Missy was working, the line is a little bit lower than it was when Jenny joined forces with her. Okay, our PPF then shifted outward, right? It shifted outward. We are able to produce more now. Okay. PPF graphs can shift depending on the resources or capital available, which we'll talk about next. Okay, so again, we saw that our line advanced outward. Factors that move the PPF outward include innovation or technology. So maybe at our bakery in this example, we get the oven 2500, and this oven has greater capacity, can cook faster, bake goods faster. We're able to produce more brownies and cookies as a result. Maybe like in this example, we hire on a new employee that's able to join forces and help produce more. Maybe we get a donation and we get some new resources that are available, like the food pantry donates some flour or chocolate chips for a fundraiser that we're doing. Or maybe we get new capital. Maybe we invest in a 3rd or 4th oven or more space or any resources for our bakery. And the results then will be more output and hopefully more revenue. Okay, when we move inward, this is a little bit more unfortunate. This is when we lose available resources, supplies, or materials. So maybe we in turn decide to donate flour or chocolate chips to a business or another company that's struggling. We lose that, so we move inward on our possibilities frontier. Maybe an employee gets fired or decides to move to a different chapter in their life. That would reduce our ability. And maybe technology regresses or we have a fire or some equipment's being faulty. That would lower our possibilities, okay? This results in less output, and as long as our prices remain the same, probably less revenue for us as a result. So earlier in the examples I shared previously, we mentioned that there are other points along the PPF, not just the ones along the curve, but any point inside the graph. So at point A, for example, represents misuse of potential resources. So at that point, if we are at point A, that indicates to us as a business or a company that we are not properly allocating or using our resources. Point B, on the other hand, is way outside of our realm right now. That is a good goal. We use PPF graphs to help make goals, but at this point with the resources available, it is not attainable. And any movement along the PPF, so from point C to D, symbolizes a reallocation of resources. So maybe we're choosing to produce more brownies and investing our eggs, flour, sugar into making brownies instead of cookies. So that's kind of the basics of PPF, or Production Possibilities Frontier. I hope this makes some sense to you. This is a great tool that you can use in your daily life and also very relevant to economics. We'll refer back to this pretty frequently, but hopefully now you're able to construct a PPF to demonstrate opportunity costs of two different outputs, interpret a PPF to make educated decisions, and finally describe the effect of external factors on a PPF graph. Thank you so much for watching. Have a great rest of your day.